Gun violence associated with civilian crime is a global problem. The magnitude of gun use in crime differs by country. According to a recent analysis of violent deaths in 24 high-income countries for 2010, the average rate of gun-related homicides per 100,000 inhabitants was 3.6 for the US, while in Europe the highest rates were recorded for Montenegro 1.87 and Cyprus 1.28. The type of gun and ammunition is highly associated with the inflicted injuries in fatal assaults. The injury patterns are essential for the differentiation between suicides, accidental deaths, and homicides with firearms. This study proposes an experimental setting to investigate the relationship between handgun and ammunition type and the inflicted injuries on a human skull proxy under controlled conditions. The study used 6 different handgun calibers, a .22 long rifle, a .38 special, a .380 automatic Colt pistol, a 9x19 mm, a .40 Smith & Wesson, and a .45 automatic Colt pistol. The National Shooting Range, located in Kambani, Hania, Greece, was used for the experiments. The range consists of outdoor trap, skeet shooting ranges, outdoor rifle ranges, and outdoor pistol ranges. The experiments were conducted using weapons and ammunition kindly provided at the range and supervised by a range safety officer. We used thin-bone spheres, which are polyurethane synthetic material, filled with ballistic gelatin and coated with a rubber layer to mimic the human head. Thin-bone spheres were mounted on a cork ring and anchored to a table at 112 cm from the ground to simulate a kneeling man of average height of 178 cm. The spheres were then fired at 30 cm distance to mimic a close-range execution. 2 of the variables tested in the study was the presence of powder tattooing and gunpowder soot around the entry wound. Powder tattooing is a result of multiple punctate abrasions on the skin because of the impact of small fragments of gunpowder, while soot deposition is a result of gas from the handgun. Soot was present in the .22 round, while powder tattooing was present both in the .22 and the .380 ACP rounds. Entrance wounds for each round are illustrated in this slide. Maximum diameter and the number of radiating fractures are increasing with the caliber dimension. Circumferential delamination is observed in 4 cases as indicated with the red arrows. Macroscopically, entrance wounds have a similar appearance with what is expected in real crania. Radiating and concentric fractures, endocranial beveling, and circumferential delamination are consistent with caliber size. The exit wounds, however, tend to be much larger than the real examples, as pointed out by Smith et al. In the 2016 publication and confirmed by this study. The thin-bone sphere shot with a .22 long rifle had no radiating or concentric fractures, but it presented endocranial beveling and it matched well visually with a documented forensic case. This is another example of a thin-bone sphere shot with a .45 ACP, which presents similar endocranial beveling and radiating fractures with the real case. This study investigated the differences in trauma patterns caused by different handguns and calibers in a series of experiments using artificial head proxies. The experiments maintained several control variables, such as same anatomical region, distance from the target, same person taking the shot, in an effort to reduce bias with the observable trauma patterns. We tested 6 different handgun calibers and recorded 7 characteristics, trying to detect similarities and differences that could help in their differentiation in future investigations of ballistic injuries. This study is designed as a proof of concept. Yet, it clearly shows some intriguing prospects for future ballistic testing using thin bone. Future work should include larger number of experiments and should also focus on ballistic testing of different anatomical regions, taking into account factors such as the presence of hair or different headwear with a variety of projectiles and other weapons in an effort to establish clear-cut diagnostic criteria for weapon identification using artificial cranial proxies. Thanks to the National Range in Hania, Manolis Kouridakis, the Cretan Field School and the University of Edinburgh.